Hello, 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 folks. Thanks for coming on by for Advent of Code Day 20. Let's get this timer started because we are mere 40 seconds away. As usual, got my TypeScript template file up, ready to go with our small test case and the big test case and this input, which I will paste. Additionally, got Quokka running, so don't need to refresh to see any of this. And for those who do not know, Advent of Code, 25 challenges released every day throughout December up until Christmas at midnight. Two-parters of varying difficulty. This one's, I think the difficulty has stopped going up, but we might have some tough ones in the next 5 days. But with that, here we go. Coordinates, okay. I see coordinates. Oh no, browser's about to be like, loading files. That's not 5,000 coordinates. Okay, that's our data scale. MME Cotton, thanks for coming on by. Oh, it's an encrypted file. Okay, we're going into the matrix. Ooh la la. Fancy. Okay, what's my example output? Now, what is the sum of the three numbers? The thousandth after 4 minus 3. Adding these together produces 3. Great, math. We can do that. Famous last words. Yeah, thanks for coming on by MME Cotton. Okay, there's a list of numbers. To mix the file, move each number forward or backward in the file. Equal list is circular. Okay, I can do this. So 1 moves between 2 and 3. 2 moves, okay, so it's all a indexing 3. 2 moves between -3 and 3. So this goes 1, 2 from its current position. I can do this. Then the grove coordinate can be found looking the 1,000th, 2,000th, and 3,000th after the 0, wrapping around. Ooh, it's a circular array. We literally implemented this last time, so don't mind if I just nope, last time. No, we're freaking or is it? Yeah, circular array. Big fan. We love those. Okay, let's see if we can reuse this a little bit. Boom, big circular array. Okay, awesome. So what we want to do is, so this basically is our circular array. So const, what do we call these? Nums. Data.split by new line, map number. Should we put them in a circular array? We're going to. Watch who's going to stop us. So now what we need to do is for each of them, we need to move forward that one. So it's for every index or for every number. Because if we go by index, then the indexes will change. Okay, what we need to do is keep track of the ones. Well, here's the thing. We're gonna have duplicate numbers, are we? Because unless you got 5,000 unique numbers in here. Oh my lord, you might actually have 5,000 unique numbers. Okay, I just need to, return 3. There we go. So let's see. New ns equals new set of nums. This is dumb. There we go. Nums dot array does not exist on type. Well, it does. It's right there. Don't be dumb. Okay. Shouldn't have circular arrayed this. Bad idea. I need to basically console log nums dot length ns dot size. See if any duplicates got removed. Okay, so it's 7 and 7, and then 5,000. There are duplicates. Okay, okay. Identity is not stable. 1, 2, -3, -3, 2, 0, 4. Okay, so I need to keep. Basically, I'll turn all these into cute little objects. So nums.map s, and then what we're gonna do is be like, oh great, congratulations, you just got num %s index. Index is I. No. Move is false. Just make a cute little complicated object. And then I. There we go. Now const nums by index equals nums.deuce. Let's see if Copilot will help us here. Thank you, Copilot. Big fan. Biggest fan. Okay, so that should allow us to do this. And now what we want to do is our for loop, which is going to be for I equals 0, 0, I nums length, correct. Then we can say const num object equals, got it. So now we're always going to get the right one no matter what. Then the fun part is actually moving this thing around. So 1 means we take its index and increase it by this, right? So const new index equals, hold on, we take its current index in the list, not its original index. So I guess original index isn't really useful for anything. So we can rename it orig index or found index. Great name. So I guess let const current index equals nums. No. Nums. Can I just say index of? They have referential equality. There we go. Const, well, here comes the fun part. Let next index is current index plus num object dot num. Here comes the fun part. If it's less than 0, wrap around. Otherwise, wrap around that way. Now the fun part, we need to splice it into nums. So nums dot splice. Well, hold on. Do we insert or do we remove first? 0, 1. We insert first, right? So, well, I'm trying to think. If my goal is to go here and I insert first, that'll be good. But if -2 goes left 2, I insert first and then I delete. I need to get your because I have to also delete at the same time. Okay, it's gonna be fun. Let's see if we can ask Copilot into nums array at next index, then delete from. We make a copy. There we go. Nums copy. This will work. So it means basically nums. Congratulations, you just got downgraded. Const nums cop. Well, no, we can't do that. Maybe that comment was on track. Let's see what Copilot has. Oh, so nums splice. Yeah, so we get rid of it. We insert the new index. Then we get rid of at the old index. Okay, here's the thing. What we can do is we can search both ways. So const left index equals index of. Now, if left index not equals next index, then we found you. Say goodbye. Nums splice at left index 1 else. Well, it's not left index. It's, what's the other one? Nums last index of, right. Pass you num nope, all the wrong symbols. All the wrong symbols. Yeah, in theory, that should work. And we want the loop of that around from there. So I guess we want one sound this number in nums array. That's not how it works. Wrapping around circular. I mean, okay, this will technically work. I'm not gonna say no. So we got the 1000th. I guess we'll just let, or we can reset your index technically. Yeah, we'll just reset your index. So, and then let, what are these? Grove chords. Congratulations, you're an array. Boop. Then we're gonna push to grove chords. Grove chords dot push. We're not saving the indexes. We're saving the numbers. Wait, the 1000th 0 after 1000th number after 0. How many zeros? Oh, this is my 0. Oh, great. Do I only have 1 0 in here too? Full match. Would you look at that? Ain't that nice? Okay, so never mind this. We want index of 0. Then we'll start moving from there. Const 0 index. Congratulations. Find index where num is 0. Correcto. Okay, now this is where we're going to start off at. So I guess we set circular dot index equals correct. That will be within the bounds, and then we 1,000 loops. Is it the 1,000th? I mean, so it's probably going to be off by 1, but we'll see about that. So much untested code here today, folks. So it's circular next dot. Come on, auto, don't fail me. Then we do it 2 more times, because that's how numbers work. 1,000, 2,000, 3,000. Grove chords, and we sum them. Reduce. Oh, well, we summed them. Good idea, though. Okay, let's see how wrong we are. 9 is not equal to 3. Understandable. What are our Grove coordinates? 3, 3, 3. Yeah, let's make sure our nums array looks right before we go crazy. So that could be wrong too. -2, 1, 2, 4. -2 will yeah. Okay, so for everyone, we're just gonna need to log its new state. Okay. Console log nums.map o.num. And let's see how badly we went. So 1, 2, -3, 3. 1, 2, -3, 3, -204. -204. Good. Then it's 1, -3, 2. 1 moves between 2 and 3. Oh, our first thing did not do well, unfortunately. Console log num object. Make sure we're touching the right one. So it's 1, 2, -3, 3, then -2, 0. Well, okay, so we're targeting the right ones. We're not even using that Boolean. I guess it wasn't needed. And then we move it forward by that much, right? So console log next index. Yeah, so 1 plus 1. Then we insert it. Did that not do its? Which one among you has failed me? We inserted it. Ah, because we're still in the thing. So we need to delete first, or... Ah, interesting. Okay, let's do the deletion first, I guess. Again, trial by fire. This code's gonna be partially unused, but... -2, 1, -2, 1, 2, 4. No, okay. Still off. So again, gotta get this basic part working. The easy part, I know doing some kind of like, ooh, move it 1 by 1. I know that will not pass part 2. Barely even pass part 1 because there are 5,000 numbers here. What we need to do is we need to move it to that index. Move object to current to next index. Don't write in comments. Don't regurgitate. I mean, this is a little different. So get rid of that current index and splice into next index. Let's find out. Okay, so it ends up like, let's show both versions. Okay, so 2, 1, -3, good, and then 2 moves between the -3s. Good. -2, 1, 2, 0. Okay, something goes wrong there. So -3 goes between -2 and 0. Right here. Where it's supposed to go. That's not where it went. Okay. Not cool, not cool. Because it's going backward, right? Yeah, so where is it? -3 is here. I remove you here. You need your old index plus 1, 2, 3. It's a circular. It's not supposed to be that hard. Math. Not even once. I probably have to need to actually step through this and handle it both for left and right splices. It feels like some of them are in fact working. So let's clean this up. Stop Quokka and get the debug on. Get the debug on. Come on. Okay, here we go. So our next index is current index, so it's 0 plus 1. I think we got that one handled. So we get rid of number at current index, so we get rid of 0. Go on, show yourself. Goodbye. And then we add it at the 1 index. Okay, yeah, that's good. Good job. 2, 1, negative 3, 3. Okay, next one is grabbing the number 2. Its current index is 1. Negative 2's current index is 1. Excuse you? Excuse you. Negative 2's current index is 0. I can't read. You're going to add 2 to it. Negative 2. Yep, it adds 2 to it. Again, I'm reading amazing this time, folks. So it's not in the bounds, you're not weird, you're cool. So you're going to get rid of the number at 0 yourself and insert it at 2. Which is between the negative 3's. Good, okay, it's just when I get to that negative 1. That's what I'm looking for. Current index is 1, next index is negative 2. Hey, we love a good wraparound. So it's basically if next index is less than current index, right? And then it wraps around to 5. So I think this might actually work. 2 moves between negative 3 and 3. Nope. Negative 3 moves between negative 2 and 0. Nah, it's been doing that. Well, dude, for all the advent of codes, it doubles as my how long this problem took timer. So we're going to splice the number at 1. So we're getting rid of negative 3. Good. And then we're going to put it at 5. It's going to be between... Oh, it's going to put it at the end. Nope. Between... Nope. Nope. Big bad. Negative 3 was between negative 2 and 0. So you went too far. Now, why did you go too far? You were moving forward. I mean, you eventually were moving forward. Freaking math. Do I need to insert? Ah, okay. If it's after, I insert first. If it's not, I insert before. Got it. Unless I did this math wrong. This math could have been wrong. Num's length. If you went back one more, that wouldn't have happened. Okay, yeah, we're just gonna manually get through this. Where's my lovely away? There we go. Got that one. Now we are on. Who will we make it to? We are on the number 2. If you're gonna go where you're gonna go. Now we're on negative 3. You should go right after 4, right before 5. So let's see you do that. There you go. Put your index at 4. Goodbye. Oh, okay. So that technically worked. Now number 3 is going to go between 0 and 4. So you're going to want to splice yourself at 5. Correct. Okay. Now negative 2 was between 4 and 1. So you go at the end of the array. That's going to be a challenge for you. Oh, your index is 0. I mean, technically, you are in the correct position, just not in this linear array. Uh-oh. I'm starting to see why this is falling apart. 0 does not move. Oh, splice out, splice in. Ain't that nice? Then who are you? 4 goes between -3 and 0. Hold up. Okay, I see where you're going. So you need to go to index 3. You're going to roll around. Good. Now, is that math correct? -3 and 0. Okay, you need to be +1. All these offsets. We love these. 4032. Okay, I think I got all these corrections made with this very small input, the teeniest of inputs. And great, we have a bunch of 4s. The heck? Your index is 4, 5. Okay, hold on. I need to see before you do that. So there, and there. Eh. 1, 2, 3, 4, 5, 6. Yeah, I don't think you should be doing that. Bunch of 4s. Not what we wanted. Let's see if at least this order is correct at the end. Nums.map o.num. So it's not going to be in the correct order, but it should be. So 1, 2, -3, 4, 0, 3, -2. So in a circular world, this should not matter. Index is 0 index, console log 0 index 5. Have I not understood? Look at the 1000th after the value 0, wrapping around as necessary. 4, -3, and 2. Okay, let's do this manually, I suppose. Let I equals 0, 4, let n equals 0, n less than 3000, and plus. And then we're going to say I plus if I greater than nums dot length. There you go. You wrap. Well, hold on. Greater than or equal to, because we don't want you to. Should be enough. I modulo 1000. Push the things or whatever. See if that does our trick. Come on. Goodbye, code. Lots of -2s. Not a fan. We're only doing this. Whoops, the N. 1, 1, 1. Interesting. Interesting. Oh, we're not using 0 index. Whoop. 3, 3, 3. Dang it, you're also. Is it 999? 304, -3. 4, -3, and 2. Well, that's not what we're doing. Okay, let's say nums was the correct, whatever you call it. Nums equals whatever numbers we want. 1, 2, -3. I'm just making sure this isn't our real issue. 3, -2. That map in. Make your cool objects. Num 0. That's literally all we need. So there we go. That's how you do a test case false. Make sure this does exactly what we want. Isolate the problem code. Lots of -2s. Great. Not exactly what we wanted at all. 1, 2, -3, 403, -2. We have that correctly now. Maybe we want to grove chords dot push nums I, right? Maybe this is what we want. Grove chords, let's drop that. 3. The 1000th number after 0 is 4. How dare you? I mean, what are we even... Nums, right? We have nums here. Okay, let's do the math. O dot non-readable. And then console log I. Am I even off? Okay, well, we're doing 2 runs, which is great. Turn 44. Stop that. Okay, index is 5. 0, 1, 2, 3, 4, 5. Giving us the number 3, as I thought. It should be giving us the number 4, which is 2 this way. How is that working? Greater than or equal to? Index is 4. 0, 1, 2, 3, 4. Ah, off by 1. I can do an off by 1. Too few. Too little. So this is 1, 2, 3, 4. Yeah, all those. If you go past, so hit the max, you roll back over. Is it literally? Yeah, I can do that. I'm not going to be happy about it. So now we're looking at index 1, 0, 1, which is number 2. Well, it needs to be negative 3, so 0. I is 1. See, this is where it's not off by 1. Yeah, it needs to... Okay, if this is what we gotta do, it doesn't feel right. Sure. Why not? I never understood. The number 1. I mean... There's nothing stopping it from being the number 1. Yeah, that's more like... That's what I thought. I was about to be like, pulling a last puzzle on us now. Why are we not looking at the correct input? Yeah, why am I looking at this? Oops. Heh. Heh. Ah. Daisy. Okay, I guess we can still see if this works for the original. And it does not, of course. Love that. So is negative 3, 2, and 1. Was my indexing off for the first one? We chose 3. It's 2 off from what we're supposed to. We give you 1,000. Oh, now you're doing stuff. Let's trust it. Come here, you. Hopefully I'm within the 60 seconds, or I'm out of the 60 seconds. Ah! 1, 2, 3, 4, 5, 6. Felt like 7 to me. No! Okay, let's keep a log now. I never thought simple, circular moving numbers would be so difficult. Not even once. So the thing is, working on the example, I'm guessing this isn't doing the right thing. Which makes sense. Gotta do it a better way. This is working at least. We can clear these out. So at least we got one piece of good working code. This is one of those things that linked lists would make manipulation easier for. But I should be able to do this without such. Okay, so let's see if we can do about this. So what we want to do is move object back forward object.num times in the circular array nums. Now, come on, Copilot. Yeah, we don't have this code. Write new code. Oh, what was that? If move, continue. Sure. Then you set move to true. There we go. Current index. Okay, fine. We're going to do the manual loop, I suppose. Excuse you. That's not... The heck? No. No, 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 no. That's worse than what I came up with. Okay, what if we manually... Yeah, so here we're just going to hit up return. It's not going to help us anything. We have this current index, num objects. Oops, just output the thing. Okay, so we need to go from 0 to 1. No, that's not the problem is. It's not going to position. Sequence. Hold on. To move one in a sequence like 4, 5, 6, 1, 7, 8, 9. The one moves one position forward. 2 positions back. Should be moved in the order they appear. Correct. Does not change in the order they are moved. We have that part. Is there a better way of managing this without like not using an actual array? We just do math. You would just set your index to this and then say, okay, everyone with this index and above, move forward. It's a brute way, but it might work. Okay, yeah, let's do this brute way. That sounds like an idea. New index. Congratulations. So we're going to say, okay, for cost n of nums if n dot found index. So we want const new index. Calculate that. Greater than or equal to new index and found. Yeah, we're going to abuse the heck out of this. There we go, great. And then n dot new index equals, well, no, it's n dot found index equals new index, but it's not n, it's num object. Great, let's clear all this out. And then what we do is we resort the thing by the thing. So nums dot sort a b, we want a dot, there you go. Then I think we got a console line up here. So you're not showing me my console log, how dare you. There it went. -3, 2, 1, 0, 2, 3. That went numerical. Why have you done this? Why have you sorted numerically? Found index greater than or equal to new index. Num object found index is this. Let's log the nums themselves. Ah. Don't know why you did that. Oop, wraparounds. Can't forget about the wraparounds. Make you a let. Drop these off by 1 adjustments. This will call you next index to not have to rewrite all that code. 1, 2, 1, 2, 4, 2, 0. No, no, no. I mean, does it actually work? Okay, it's not working. I was like, are we lucky? No, we're not. So 1, 2, That's not how that should have worked. Yeah, what did I do with index math? I really messed index math up. So there are 1, 2, 3, 4, 5, 6, 7. Someone was like, let's go to number 9. Like, who do you think you are? Maybe I didn't need those -1s and +1s. Again, someone's thinking they're going to the moon. Next index. 1, 3, 5. You only have, yeah, come on, get in there. 0, 1, 2, 3, 4, 5, 6. You only got 6 things. So whoever thought, oh, everyone did think cool. 1, 2. Do I have to flatten each one down now? Ooh, I'm doing it to myself, aren't I? Actually, that doesn't matter because I reassign myself. If the found index is greater than the next index. Ooh, while. No, it should. Eh. Stop. No, I guess we put something there for me to break onto. Our brain is failing on this one. Okay, so our current index is 0. We're going to 1. So everyone who's currently at 1, you gotta get out of the way. So everyone basically increments, which should be fine. So yep, we got all these lovelies. So 2, 3, yeah, y'all get incremented. Congratulations. Yep, everyone increments. We love that. Move on. Whoa, not that button. Where is it? Yep, great. Everyone incremented, and then when you increment, you have to also wrap around. Also, understandable, understandable. So now you are an index 1, but 4 didn't go back to 0. Got it. That's our trick. And found index. If and found index greater than num's length. Yes, this is for a single incrementation. This should be stable. Get clock up, back up. -3. 3. Dag, nabbit. Got 2 zeros. Right. So we'll put a while in found index. Yeah, I'll put this in a while loop while we're at it. Boop. Is that cool? -2, 3, 3, 0, 1. No. No. Brain. Maybe I should go back to the splice. Yeah, it's gotta be the splice. So let's head on back to splice. Should not have abandoned it so soonly. Let's do a new splice. Okay, so that is always our next index. Yep, and then we're gonna remove it and then insert it. That should be all we need to do. So let's okay, just gotta do this math here. If it goes the negative though, splicing the current index is actually the easy part. And if it goes negative, what if our new one goes negative? Okay, so leave this off. So, yep, splice the current index, get rid of it, put it in the next index. I think we'll use the cool nums.length, right? That's the cool way of doing it. Actually, does the modulo... Oh, don't do that terminal. No. -5 modulo 5 makes it a 0. Oh, dang, I tried on -4 modulo 6. 4, 2, 3. Okay, it does seem to be doing something. Maybe the negative will be sufficient. Yeah, so current index. Yeah, we don't even need to do any of this logic, maybe? Maybe. Don't forget to put that in there. Nope, not there. It's just current index like that. -2 to equal -3. Great, what are my nums? 1, 2, -3. and then 3. How dare you? Hmm. Yeah, nums by index. This is always the right one, right? Num object dot num, right? So 1, 2, -3, 3, -2, 0, 4. So I am grabbing the right one. I'm getting rid of you at the current index, which is index of, big fan. I'm inserting you at the next one, modulo this lovely list. Huh. Is it at least in the wrong order sorted correctly? 1, 2, -3, 3, -2, 0, 4. Heh. Let's drop that one off, I guess. Nums by index, most found index, console. Yep, giant object, kind of as expected. Numbers by index, original index, is correct. Maybe this is our problem. I thought it'd be an efficiency, or maybe... No, we already know it's giving me the right one. It's just inserting in the wrong place. Hmm. Ah. I think a circular array would best me. Huh. Okay, let's start Quokka. Manually step through this, see where I have gone wrong. Okay, so we've already removed from current index because we've done that up there from 0, and now we are going to reinsert it at whatever this is, which is inserting it back at index 1. Yeah, that's good. And we're gonna let's remove some of these. Yeah, okay, out of space. Which one can we say goodbye to? Goodbye, bye, goodbye, goodbye. Real-time performance. We know we are real-timely, not going fast. Give me a little bit of reeling. It ends on Christmas, well, dude. So Christmas, Christmas Eve is the last night. Inserting at index 2. Ooh, num's length. That changes when I actually get rid of this. That's a problem, I bet. I need to use a different length, one that does not change. Or do I? Let's put the whole thing in a thing. Boop. Yeah, still equaling 2. So 0, 1, 2. It's gonna put itself 1, -3, 2, 3. Okay, so that works. Then 3 goes between -2 and 0. So we say goodbye to that one. Then it goes to position 4. Well, that's -2, so I don't know how you're gonna handle that. I guess it might go to position 4. -2. Oh, I forgot you could splice negatives. So it's -2, -3, 0. Okay, that's working. You're going to get rid of you at index 2. So this is 3 goes between 0 and 4. You go forward. Awesome. Modulo 5. Going at index 5. 0, 3, 4. Good. -2 goes to 4 and 1. End of array. Understandable. Get back in there. Oh, where'd you close all my things? There you go. So you're about to say goodbye at index 2. -2 goes away. Then you insert yourself. Current index plus 2 will 0. And that's true. Your index is 2, and you're adding -2. Yeah. Yes. But you're going to insert index 0. Which isn't where I want you to go. I want you to go to the end of the thing. But this doesn't break the order. It's just weird. Because you're just over here instead of over here. So it's still 1, 2, -3, 0, 3, 4, and then -2. So that still works, technically. Who are you? You are 4. You're gonna... Oh, you're a 0, so you're gonna go to the same place. So going from 4 to 4. Wow. -303 still works. And you are at index 6. Ooh, notice how that changed. You were going to index 3, now you're going to index 4. Is this your problem? So you're supposed to go between -3 and 0. If you're off by 1, this is the issue. -3 and 0. -3, 4, 0, 3. Oh, that's correct. Well, this is correct. Why was I doing this? Oh, why was I stepping through this, like, at all? It did all the things as I was expecting it to. When were you planning on misbehaving? Grove chords, -2, 3, 3. Okay, so these ones are the problem, because 1, 2, 3, 3. This wasn't what you... Oh, freaking sort. Ah, we love this. We love when you leave over old code. We love this. Big fan of old code. Okay. Multiply each number before you begin. Mix the list of numbers 10 times. Does not change. Oh, okay. I don't know what... Okay, I'm obviously missing the complexities of part 2 in this equation, but we shall try. I guess if you weren't using a splice method, you'd be like moving by billions increments or something. Move all breakpoints. Let's clear all this up as we copy. Big fan. What's my... Great, this is my for the sample, my expected for the chapel. One sample in question. Get in here. Love it. Now all what I have to do is multiply each number before I begin. Great, I can do this. So take number. Where do I want to do it? Here's a good place to do it. Boom, we can do multiplication. Mix the list of number 10 times. The order does not change in mixing. Okay, so that changes all. That doesn't change at all. Easy. For let m equal 0. 0, a 0, m less than 10, m plus plus, 10 layers of mixing. It's gonna run a little bit longer, but big number. Okay. There's something else. Okay. I guess in certain languages that would have been more difficult, or if you had not done the part two correctly, but I just spent too long fighting it, that also would have been a bigger challenge. Did I get for part one? Because I know it was above 1,000. Not too bad. Not too bad. Yeah, that was pretty good for day 20. So I guess it did pay off, at least in part two, for me to fight with the splices. But yeah, put that in your Anki. If you want to move something from one index to another index, first you remove it, and then you splice it just like that against the current length, which does change, and that works out somehow. Though it doesn't really work out because it was off by one, but if it's a circular array, it doesn't matter. I guess we never got to use that, did we? That's okay. Let's go ahead and make this a lovely commit to day TypeScript solution. And then we'll head on for the optimization, which honestly, not much algorithmic optimization. It's just gonna be more of making the code less wet. So let's try out this code. First, I guess it's the entire part. It's most of it actually. The only thing that changes is how many times we mix it. Oh, left a comment. So I could variabilize a number of mixes and the multiplication, or I break this into 3 cute little functions and this gets improved. I like functional stuff, so let's break into 3 cute functions. Function parse. What do they call this in the story? Encrypted file. Numbers. Parse numbers equals. Thank you. Well, that's not exactly what we're doing. So we do want to keep the original index. So this and I. Whoops. So again, I love object. Big fan of object. Number and then index. Big fan. Why is this angry? Why are you angry? Oh, because I was like, function. So that's not an arrow function. And we're also going to return the by indexes one. So let's go ahead and say const numbers. Congratulations. I guess we could do that as a side effect. Let const map equals new map. Yeah, no one ever said it can't do a side effect. You just gotta watch out for them. Yep, come on, get in there. Yep, get in there, symbol. By side effect, I mean a map that does technically the job also of for each. So instead of returning this, we're going to say const number equals congratulations, return number, and then we're going to say bingo bango. We'll put that in our lovely map. So we can return numbers and map. Beautiful. Const numbers map equals parse numbers. Got that. Now what do we call this process? Mixing. Okay, so again, another cute function. Mix numbers. Numbers. Oh, this is weird. I'm calling it. I got my own little weird interface. Okay, there has to be a better way of this. File is encrypted. Remove each number. File number. Weird. Whatever. We'll find some name for this. I guess at this point we can call it a value and index. Oh, come on, get F2 on there. Cool, gotta love VS Code sometimes. Number implies any. Don't worry, you're cool. Where are we gonna say this? Why are you angry about that? Okay, it just got confused real quick. Be this file. Okay, yeah, it's like incomplete code. What do you think you're doing? Don't you worry, TypeScript. From number to a file number. And we get to call these. So we'll call you a lovely file number away. Beautiful. I love TypeScript. TypeScript saves the day. Oh, that's wrong. Bingo, bango. Beautiful. So the mixing is basically, whoa, Copilot. Don't get too ahead of yourself. Boop. There it is. And then we have our map. Got get file number. Lovely. Don't worry, it's always gonna be there. It's not assignable to end. Why are you angry? Why are you angry? Oh, I grabbed a different number. And boom, drop our value. Lovely. You're still angry about something. Yeah, we'll make that cool and chainable. Beautiful. Then what we're going to do is here, we're going to say mix numbers, numbers and map. Big fan, big fan. Things on fire though, cause cannot read undefined reading value. Why you know do your job index of? Or why you know do your job I? Map.get I. Whoop, you're supposed to be an index. Oops a daisy. Lovely. Now what are you angry about? This thing is getting angry like every 5 seconds. Just chill. Okay, so this should do the magic. Let's optimize this Grove coordinate thing, because if I remember, it's just the 1000th, 2000th, and 3000th number, and that can just be modulus. But my brain was like, that's so difficult. So let's get this working. I missed one. And then all of these be value. Value. Lovely, big fan. I could have done an index of based on index of map.get 0. Don't worry, I promise it's there. Great, so what are Grove chords? Great, we see those. I've already broken it. Awesome. Awesome, awesome, awesome. Jeez Louise. Numbers. 2, 1, 2, 3, 4, 3. Alright, we know it's broken that way, but 1, 2, negative 3, 4. 1, 2, negative 3, 4. 3, negative 2. I bet this is wrong. Let's go back a little. Step back. Wait a minute. Okay, so that works. Versus. So yeah, what 0 index did you spit out? Come on, 5. Versus numbers index of map.get 0, which should. Oh, that's index 0, not value 0. Gotcha. Yep, we only need to, because we're doing this once, no need to index by it. Cool, 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 cool. Let's update these Grove chords to, instead of being this, so basically I'm just gonna be like, okay, let's get rid of all of you. Just so I can get this working first. The length, and here comes the new one, so it's going to be 2000, 3000, that map. This is going to be every index, or index offset, so IO, so it's going to be 0 index plus IO modulo. Oh, okay, it's doing something. There you go. That's the idea. I don't see why this is a bad idea. Number is not precisable to not number. Oh, God, that. No, okay. Let's see what it changed to. Oh, clock is just like, how dare you? I like to see this. Cannot read undefined reading value. Aha, remember order of operations. Modulo runs before additions. Hey, look at that. Man. It's definitely the way we're going to do this. Let's further optimize it. No variable needed. Goodbye, variable. You will not be missed. And finally, we don't need a double map. We can straight up use... First, we don't need a double map. Easy. Just put that straight into this. Second, remember, whenever you see a map and then a reduce, that could have... IO. No, get out of there. That can always be simplified into a single reduce, so let's do that. Da-da-da-da-da-da-da-da-da-do. IO, so accumulator plus this big old number right here. And we're going to change this to sum, be a little more contextually accurate. And with that, that should be the trick. I think this can even be further functionalized. Function, sum, grove. What are these? Grove coordinates. And this is going to take numbers, which is an array of file numbers. It's just going to do these two lines right here. Boop, bop. Lovely, big fan. And since I made this chainable, well, we can just go return passing numbers. Easy. Hey, Dumpster Dev, how's it going? Thanks for coming on by. We're just finishing our polish of today's solution. It was a circular array of all things, which took me like an hour to do because I have failed. Anki has failed me. Hey, glad to hear it. Glad to hear it. Oh, you know, if we make this return array, that'd be cool. How cool would that be? Be so cool. TypeScript's not cool with it, but we're cool with it. Numbers is a file number away, and then this is a map of numbers to file number. I suppose so, yeah. It's easier to blame it on some inanimate piece of technology, you know, though? It does feel like it goes on, like when you say, like, oh, that was easy, and it's like, great, you won't see it for 3 months. It's like, whoa, I didn't say it was that easy, you know? So sometimes it's like, dang, I should have pushed hard if I knew you were going to throw it that far away, but yeah, it's all about choosing the more accurate version, really. Okay, now we have these. Do more chaining, because we weren't doing enough chaining before. Yeah, come on. Dot. Nope, too much chaining. Too many nope, good chaining. There we go. So, yeah, super readable code, but yeah, I like it. Turned out nice and functional. Yeah, that's pretty good to me. And now part two, I'm just going to use all of these with the addition that we're going to do 10 mixes and not one. Let's see how we're going to get that in here. So I guess we're going to want our const numbers and our map. Just going to do this 10 times. So there you go. And then we can use our old looper right here. Mix numbers, pass both things, then return the summation of the grove coordinates. Huh. Ooh, we also have to do a map multiplication, right? So numbers dot map or for each. Or constant num of numbers. Ooh, numbers. I know how to spell words. Num dot value times equal big number. I got rid of the big number. The big number has returned. Boom, there we go. Big math. And again, I'm assuming thanks to good old JavaScript, I did not have to do any weird handling of big numbers, which I imagine is what part 2 forced a lot of others to do. Yeah, this works pretty well. I could do something cheeky with like an array, but I wouldn't be able to embed the multiplication of the numbers, would I? Unless I manipulated this, which would be ugly. Super ugly. Okay, we could do something like this. Parse int, which takes string and returns number. Yeah, we can do something like this, where parse int, and gosh, how do I set this equals parse? Oh, that's gonna confuse the heck out of you. Yeah, you can't do that. Transform value. Oh, great. Parse int slightly. I don't know. Everything's on fire. Let's set it over here. There you go. So now we use this cute little thing, and what did that do for us? That gave us the power. We have the power to now take in a string and be like parse int string times big number. There we go. So we just embedded that in our code since we're already using parse int. Now this makes it possible to do the super scaling. So I think it's array.from length 10, and what we want to do is for each of them, I'm trying to think of the best way to do this. Reduce numbers. I guess we're not, I mean, we are doing reduce because we're passing from old to new. Last numbers, so technically it's always a reference, so this practically does nothing, but to maintain the spirit, I guess. Next numbers map, but we are reducing not over this, we're reducing over numbers. Alright, and each of these values is that, so yeah, we don't actually come on, you're supposed to be an unknown. Ooh, you're also what's returned every time. So maybe alright, so you're gonna use last numbers. Well, hold on, why are you angry about that? You're not unknown. But we are using a value reduce of each of the next ones, right? Ah, okay, this might be a little too much for TypeScript. Here I want a map. A map that doesn't do anything, of course. Not very functional. But this will work and technically allow me to pass. No, it needs to be a reduce. We're gonna reduce dagnabbit, whether it lacks it or not. What signature have you generated? Previous values unknown. Initial values unknown. Well, how dare you? This is an array of file numbers. Usually we're supposed to be cool with this. Why are you not being cool? Okay, the number 1. You cool now? Okay, now that's being cool. I guess since it didn't initialize with something. That's why it's freaking out. Fill with undefined. Oh yeah, I have seen it. I'm supposed to have it installed. Where is that? Ah, I could have swore I installed it. Or maybe I saw it, but I didn't install it. Yeah, that's what it called. Ooh, yeah, okay, yeah, I saw their tweet talking about that, but it didn't have that installed at the moment. Or it didn't have that included, yeah. Yeah, this would be a great example. Download the extension, sure. I'll figure out your name in a moment. It's this thing. Total TypeScript. Oh, they changed the name. No wonder I can't find it. Neat. Yep. Mm-hmm. Yeah, but it's supposed to have links straight to the docs, which I always appreciate. Yes, I would love some helpful hints. Stop freaking out. What did I call my... Yeah, I want to see all the tips. Give tips. Okay. Now fix my code. Argument unknown is not assignable. Okay, we kind of know that. When do we... Yeah, for sure. We might need to do simpler things. Const A equals 1. A... I will just do an example 1. 1, 2, 3. 3A plus equal 4. Let's see if this will tell us stuff. Cannot assign because it is a constant. Or have I failed to install it? Oh, contribute a translation. Okay, it's not there. Let's so okay, that's cool. I'm glad it's open source. You can contribute. That's cool. Let's see which one they're using on. Explicitly has an annual. I don't have my TypeScript turned up that high. Oh, here's one. Yeah. Annotation tells the function what type the parameter should be. There we go. Basic types. Yeah, there we go. I hope that's an unrelated error. Return type. Any type. Yeah. Okay, yeah, it is working. I'm just highlighting on the wrong things. But yeah, definitely pretty good for beginners. It adds this, as you can see, this blue underline to any usage of TypeScript. So if you open up a code base and it's like, there's a lot of TypeScript here, I don't understand any of it. You can have it taught to you by hover overing all of these. And like, let's see, this is a great explanation of as. Tell TypeScript you know better than it does. Yeah. What's this new more link do? Looks like we're going straight to the docs. Nice. Okay. Beautiful extension. And now that I've done this, though, can I get back to the docs? Ah, so once I, like, say I've learned it, doesn't give me the option to go back. I guess that makes sense as a teaching tool. See full translation. Oh, now it's kicking in. Okay, I just had to give it a moment. I was expecting file number, but you passed unknown. Yeah, that's definitely a more English understandable than argument of type unknown is not assignable to parameter. There we go. Where does this go? Yeah, thanks for reminding me of that, whoa dude. TypeScript error translator. Nice. Oh, you can just shove errors in here. Oh, let me shove an error in here. Um, okay, I guess in my current TypeScript that's not an error. There we go. There you go. I was expecting a type matching A, but instead you passed B. Well, you mean you were able to pull the information out last time. I guess the extension got a little confused there. Let's change this to something else. Is my thing. Okay, jeez. Is my spelling? Oh, okay, interesting. My C spell is not allowing this thing to come through all the way. That's kind of sad, and I think that's a bug. Because, I mean, we already got 1, 2, 3 hovers. There's no reason we can't have 4. That kind of sucks. Yeah, so if you're wondering why this thing doesn't show up, make sure you don't have a bunch of other highlights blocking your path. That's a nice little error translator. Ooh, and they bring their own explanations. I'm guessing, since it's so fresh, they're definitely gonna improve this to be parsing out these eventually. But yeah, again, thanks again for reminding me. Now let's actually solve this error, because poor TypeScript is just like, hey, why are you angry? I don't know why TypeScript's freaking out on this. It's because it's fill of nulls, right? Will that make you happy? Of undefineds. You're just so confused. Okay, I think we're gonna do something you don't generally want to do, but we're gonna tell it exactly what is up. I think we can pass generics to this. How do we genericize you? Yeah, where's the T? Oh, you not? There it is, the U. Where's the U? Previous value is the U. Oh, that's the only thing we got. Okay, fine. Previous value is the U. Congratulations. You're a bunch of nulls. There we go. Okay. File number. Array of file numbers. Ooh, happy TypeScript. Means we can drop this. Like so. And drop that too while we're at it. Bingo. Bango. Oops. A delito too mucho. What was the whole point of doing this? Why did we want to do this in a weird way instead of cool, readable, normal for loop way? Well, this is functional. The thing of functional is that you can pass it to stuff, like right there. So we can just pass it to something else. And the great thing about functional again, we need access to map, don't we? Okay, so we can't go super functional. That's functional enough. And yeah, there we go. 10 lovely mixins. Oh, what's this? A not null expression. Postfix an expression of exclamation point. Beautiful. Why does this thing keep yelling at me? Is this some other dumb extension? Ooh, what's this? Just like functions, you can pass types to other types. Lovely. Anything else you want to teach us? Variable type annotation, correct. Return type, ooh, the tuple. Yeah, we love a good tuple. An interface declaration. Big fan again. Yeah, TypeScript. It's a pretty great extension. Or this total TypeScript, as they call it now. Yeah, with that, we are done with this problemo. Go ahead and get a commit on this and wake up Git. Git has abandoned us. Where'd my terminal go? I drug it around by accident. Git status. Yep, it's solutions. Today's day 20, I'll have you know. I went that long without a single save. Wow. That's on me then. 2022. Day 20. TypeScript solution. Lovely. But yeah, final review. What this does is first what we do is we take every number, which is just a line per thing, and we transform it into a number. This is with parseInt or parseInt times multiply. And we additionally grab the original index of that number. Now first we're just going to return that array of objects, but we're also going to save it in a map. The reason we save it in a map is because for each iteration we're going to want to look up the number by its original index. So we always want to basically have that available to us. Just like databases index certain columns, we're effectively doing this for us, as hash map lookups are O of 1. So we sacrifice memory, the memory the hash map takes up, for speed. Then we return as a lovely tuple. Finally, our mixer goes through every number in the thing, grabbing the one by the current index. So by the index 0, 1, 2, using that O of 1 lookup map we created. Gets the index in the actual array of it with index of. We can use index of here because we're looking for the same object, so it uses referential quality. Then we get rid of it. We say delete from your current position with splice, which says starting at current index, delete one item. Then to put it back in the array, we say current index plus however many we want to change it by, modulo the length of the array without this in it, which does work, though it messes the order up a little bit, but enough that it doesn't matter for us. And instead of saying delete stuff, we say do nothing, and instead insert something. So like these are the arguments you would push to push. Finally, we return it. This makes it chainable. Chainable being that we can pass it to something else, like some grove coordinates, which finds the index of the number with the value of 0, so not the index of 0, so we do a single find index. Then for each of our desired circular indexes, we say, okay, take the original index, add it to 1, 2, and 3000, modulo, so it wraps around, and then grab the index of that number, and take its value. The rest of this is a classic summation reduce. Now solve 1, since we wrote a bit functionally, we just pass all the things. Solve 2 couldn't be done as functionally, but we grab the numbers and the map, use our parseInt custom transformation to multiply it by a big number. Then we do a cheeky little array from length of 10 to functionally basically do a for loop. And then we do reduce because we just want to, as mixed numbers always returns the next reference to the same array. So it's always returning the new one, basically rolling over that particular value. Initializing, of course, with numbers, and the functional stopper is that we need a map to always reference. And yeah, that is this code. Let's give it push. And I want to check out Total TypeScript a little more. Let's TypeScript hero. That's something else. We don't care about you. Oh yeah, Total TypeScript. So this is good. And there are no it's the repo, I suppose. There's a way out, because the thing is, like, as cool as that was, what if I'm like, oh no, I didn't mean to say I learned it. I'd like to see the docs for interfaces again. That'd be very cool if I could see interface docs. But they're gone. They're in the void. They're poofed away. How do I get it back? Where are your list of commands? Show me the power! Where's the thingy? There's a thingy here, like, in extensions that's supposed to list all the things you can do with this. I mean, somehow it's working by marking these off. What's this? Oh, multi-repo. Okay, never heard of that one. Where, I guess we're doing here. Parser, searcher, config. Yeah, config. That's what I want to know. This isn't what I was looking for. Apps. Oh, that's cool. They have a web version. Big fan, big fan. Oh, there's another package down here. Let's. Ah, here it is. Okay, awesome. Show full translation. There's show TLDR. Hide all tags. Hidden tips. Hide basic tips. Okay, those are my configs. Where are my commands? Ah, these are my configs. Okay. I guess I might as well. I was looking for a little more. It's a new extension. Show full. Yeah, we'll show full. I figured VS Code just like dying over here. Okay, where are you storing all that config information though? I know you're storing it somewhere. Where are you showing the stuff? I'll look in your test case, don't make me. I know it's gotta be storing it somewhere. Nope, that's not it. Okay. Somewhere you're creating a decorator and I'm clicking the decorator. Where is the command you're executing? Activate, update hidden, show tips, show beginner. Yeah, register command. Don't show again. Ah, this is the magic command. Update hidden tips. Oh, so you store them in the settings. Where's open doing total word match? What are we calling this again? Don't show again. Wait, you're not in here.